Before we get into chapter 12, take a look at these prerequisite concepts. Chapter 12 is all about linear equations. The title is uh, linear regression and correlation, if I remember correctly. So let's review a little bit about lines. You might remember the slope-intercept form of a line from your algebra class. It's more commonly known as y equals mx plus b. Let's just point out the different aspects. So the slope-intercept form, we use that word because there are really two important features, right? Y equals mx plus b. M represents our slope. B represents the y-intercept. And a little bit more on those. The slope is the change in y divided by the change in x, or you say it's like a ratio, the ratio of the change in y to the change in x. So that's going to be big for us in working with lines and even interpreting what the slopes mean. Okay. And the b, well, that's the y-intercept where the graph passes through the y-axis. Technically, it's the point 0b. But when it comes into the context of, an application, think of it like an initial value. That's the initial y value. When x equals 0, that's the value that y takes. And then as x increases, then it starts to move up or down depending on the slope. Okay. What else do we need to know? Statistics notation. So in statistics is really its all own brand of thinking, and it has all of its own language and applications and that sort of thing. And it's got its own notation. So statisticians don't use the y equals mx plus b form. They think of it like this: y equals a plus bx. So they reverse the order of the two pieces, and you can see I even got mixed up here. So a is your y-intercept, your constant, and your number multiplied by x is always your slope. So they've taken the two and switched the places. And they call it A and B because first two letters of the alphabet. Keep it simpler that way. So we're going to generate these sort of lines using StatCrunch, and it's going to present it to us in this style: y equals a plus bx. We'll have numbers there for a and b. Just to give a couple of examples of the sort of things we'll see, we get a lot of rounded numbers, right? So here's two examples just to be familiar. So how about y equals 32 plus 539 plus 16.017x. So that's the equation of a line. Turns out that these things are going to be generated given some kind of data. I decided to do another one, I guess. Y equals 121.703 minus 8.688x. So there we've got a negative slope. You might remember a positive slope goes upwards. A negative slope goes downwards. Okay. What else might we say? What are just the names that we give to the variables? So x we refer to as the explanatory variable in statistics. Y we refer to as the response variable. So you might remember from algebra that we call x and y the independent variable and y is the dependent variable. So kind of a similar thing going on, just different language. So we say the x value explains the y value, and the y value is a response to the x value. So we'll kind of see this in problems, obviously. Okay. And finally, I've got a couple of examples about interpreting slope. So we'll see this when it comes to later problems. Thinking about it now is going to set us up so that we get these things very naturally later on in the bigger problem context. interpret the slope, we'll go through two. Let's say the explanatory variable is describing weeks, and the response variable describes pounds. And they tell us that the slope, and remember slope is represented with the b, the slope is 5/2. What would that mean? How would we interpret that slope? You know, if we have these units and these numbers. Okay, so remember that the number on top is the change in y, and y is the response variable. So this, the units of that 5 is pounds. The number on bottom is the change in x, and x is the explanatory variable. I kind of like the explanatory variable. Helps you to remember that it's an x. This is weeks. So what is this slope trying to tell us? Here's one way to say it. For every 2 weeks, we gain 5 pounds. They're both positive numbers, right? So as 2 weeks pass, then our pounds goes up. We have a positive slope. Let's do one more. How about this? And we'll get this decimal value for the slope now. Let's say the explanatory variable represents hours. The response variable represents dollars. And we find the slope to be negative 14.207. How would we interpret that? Well, we need to think of it like a ratio. So put it over 1. And you might remember doing this sort of thing in algebra. Think of it as negative 14.207 all over 1. And we know that the number on top, has the y units. So that's the response variable dollars. The number on bottom is the x units, hours. So what is this trying to tell us? Well, one way to say it maybe, for every 1 hour, we lost $14.207. It's negative, so we need to indicate that that went down. I think the word lost does that well here. Okay, there's your prereqs. Go ahead and read the first part of the chapter if you haven't already, and we'll pick it up in practice number 1.